Welcome back to the Cloudcast. I'm your host, Brian Gracely. And, one of the things that we've talked about for a long time, and it's an ever-evolving topic, is how do we make it easier for developers to be productive, for developers to adopt new tools, to be able to understand how to translate business needs, which are ever evolving, ever asking to go faster, and turn that into technology, turn it into software. And we've oftentimes called that paths, we've called that developer experience, we've called it a whole lot of different things. And today we want to really dive into not only one of the technologies that's kind of at the forefront of this, but also really kind of dive into, how is that developer experience evolved over time. And so very excited to dive into that today with Matt Butcher, who is CEO of Fermyon and friend of the show and guest of the show a couple of times before. So Matt, great to have you back.
Yeah, thanks for having me.
It's been a couple of years since we last had you on, and Fermyon is a company who has been at the forefront of WebAssembly, or WASM as some people know. But for folks who either didn't get a chance to listen to that show or may not know you or Fermyon, give us just a quick background and then the areas that you're really focused on these days.
Yeah, sure. And I've sort of made a career sort of out of cloud, I guess. I started early on in web development and then made my way into CMSs and then into OpenStack and on into Kubernetes and all of that. So, that's my background is very much oriented around that kind of server-side computing, infrastructure computing and stuff like that. And we were working at a startup in Boulder called Deus, and Deus was building a PaaS, and we were building a PaaS on top of Kubernetes. We were building it before Kubernetes was around, and when Kubernetes landed, we decided to re-platform on top of Kubernetes at very, very early, like Kubernetes 1.0, 1.1, I think was when we really started doing that. It went well, and out of it, a number of interesting things sort of came into being, one of which was Helm. We wrote the package manager for Kubernetes originally to install our own PaaS, and it just kind of grew well beyond its original purpose, and that all caught the attention of Microsoft, and Deus ended up getting acquired by Microsoft, and it's actually fabulous. I mean, I kind of grew up in the era in which Microsoft was sort of the bad guy, right? And Microsoft was the Borg. Right, they were going to embrace, extend, that kind of thing. But under Satya, things there had really changed. And in particular, their view of open source had gone from, what did Steve Ballmer call? I think he called Linux
cancer.
Cancer. That was, yeah.
That's right.
They went from that to like Satya going, okay, not only have we missed the boat, but we need to fix it. Like, we were in the wrong, and we need to start building good community goodwill. We need to be good participants. And they've gone by fits and starts, right? It's a gigantic corporation, and they're gonna have some, silly missteps. But we were really fortunate, and that, the Deus group kind of came in and got split in two, and half went and built AKS, the Azure Kubernetes service, and the other half of us, we really just did open source upstream with CNCF and Linux Foundation and those kinds of organizations all the time. And it was one of the best jobs I've ever had. It was just fantastic. But our big goal there was to figure out what was causing people to struggle in their move to the cloud in general, but really more specifically into containers and Kubernetes, right? What hiccups were organizations having? What were the hardships that individual developers were hitting? What kind of tools just hadn't been created yet? And then we would, take that information and try to solve problems. I think we did. I think we've released over 10 open source projects into CNCF and Linux Foundation during the time I was there. So in that regard, we were very successful. But we always kind of we had this list of things that we just never could figure out how to do with the existing tools. One of them was like, we were trying to figure out how to get nearly instant startup time for a cloud runtime. So, containers are virtual machines. Because if you can do it, then you can do what's called scale to zero, where you can, when no traffic is coming in, you scale all the way down to zero in your proxy. And when 10,000 brand new requests just start up instantly, you can instantly spawn enough handlers to be able to deal with it. That was seemed like an intractable problem at the time. We tried it several different ways with containers, with virtual machines, with unikernels, couldn't crack that one. Another one like that was we were continually hearing from developers that the frustrating thing about building Docker was that their development process had to be attuned to the infrastructure into which they were deploying. So developers who were used to developing on Windows were finding that they were building containers for Linux. And when the infrastructure team started rolling out ARM processors, all these people used to, developing on their local Intel workstations were suddenly cross-compiling and taking a huge performance hit. And strange bugs were coming up, and Docker files had to be rewritten, and different Linux distributions had to be used, and people were frustrated with that. And so we had amassed this list of things like that, and at one point said, well, if we were going to take a shot at solving some of these problems, what would we do, right? If we went out of the box and stopped talking about containers and virtual machines as the two kinds of cloud computing, what would we do? And we decided we'd look around and see if there was another class of cloud runtime. If there was basically something left to be discovered. And the kind of surprising conclusion was we discovered that WebAssembly, this sandboxed environment, binary format designed to run in the web browsers, actually checked off all the checkboxes for being a good cloud runtime, and it solved many of those problems we were interested in. Mm-hmm. So, I don't know, I think you and I first talked, I think at KubeCon Detroit, or at least that's the first time I remember. Yeah. And right around then was when we really first kind of launched publicly Fermyon and what Fermyon was doing, which was taking WebAssembly and using it to build kind of a third wave of cloud computing. Right. And that's what we've been doing for the last few years. Yeah, it's probably a longer intro than I intended to give at the beginning. But
it's good. It's good and it's helpful because I think first and foremost it provides some context. There's always there's always the need for good context whenever something new comes along, because we do have a tendency in our industry to sometimes it's sort of like, well, I just built something, and then you can't answer the question of like, well, why did you build it, other than like it seemed kind of cool to do. So I appreciate all that, and and the other thing is, these days there is a tendency for us to all sort of have this selective memory or memory that is so scatterbrained these days, because there's so much coming at us, and these days everything is sort of AI. So it's good to sort of be like, oh yeah, there is other stuff in the world other than than that stuff. Let's talk a little bit just for to give folks some context. So WebAssembly's been around for a little while. You guys, obviously, it wasn't something that you necessarily invented, right? It was, like you said, it's technology that originally was kind of embedded in the browser. But give us a sense of where is the WebAssembly community? What types of things is it focused on? What's going on in the open source part of it before we dive into kind of specifically what you guys are doing with it?
I think WebAssembly has a really cool origin story, and one that you actually, once you start to see the pattern that WebAssembly followed, you actually see this happen in other really cool, groundbreaking technologies, where it was invented for one reason, and then sort of outgrew its original purpose in really interesting and delightful ways. So what was the problem WebAssembly was invented to solve? It was a problem that really Java was the technology that took the first shot at this, which was back in the 90s. Browser vendors were trying to build a way to write what they were calling at the time like real applications that ran inside the browser, right? We call them web applications now. Right. And Java applets were the first attempt to crack this, where they built a technology that they could plug into the browser that would, claim a segment of your browser window and be able to paint a full windowing toolkit inside of it. And you could write, buttons and radio buttons and text entry fields and all of that, and then run a full thing of code, full battery of code locally. It didn't take off though. Part of the reason it didn't take off was that it always felt like it wasn't really quite the same thing as the rest of the web technologies. But part of it was because Sun was proprietary and kept Java as did not embrace the early open source movement. And then the third reason is, the language that they created to help glue Java to the browser, originally called LiveScript, turned into JavaScript, which turned into like the thing, right? And we could accomplish so much more with JavaScript. Why do we need a big, clunky, slow language to do a fraction of what you can do with JavaScript? So, but the idea sort of stuck and it resurfaced several times. We saw it with Adobe and Flash, Microsoft and Silverlight. A variety of languages or language ecosystems tried to sort of make their way into the browser. Why? Well, because as good as JavaScript is, it is not the be-all and end-all of the programming language world, and there are always reasons that you would want to use other languages. WebAssembly kind of followed that tradition, but broke off in a crucial way, right? They said, okay, all these other technologies, Silverlight, Flash, Java, they've all been proprietary single vendor solutions. What if, and also they've all been rather large in scope, right? They handle the graphical part, they handle the low-level coding part. Oftentimes they come with their own compilers and build environments and all of that. They said, what if we just carved off one little piece of that problem and said, let's build an open source, standards-based runtime that just you can compile whatever language to, and it'll run in your web browser. And the kinds of use cases they had in mind, this one actually is not, I thought this was mythical for many years, and I found out just about 6 months ago this is actually true. The use cases they had in mind were things like old C libraries that needed to be, that you didn't necessarily want to rewrite in Java, or high performance vector like what Figma does. There was a myth for a while, what I thought was a myth and turns out to be true. There was a story for a while circulating that when Microsoft went to port Office to the web, some of the code was shockingly old and also not well documented. And also the people who had written it had since retired. And so there's this story that there was a library that did some important number crunching inside of Excel. And nobody knew exactly how it worked. And it really, for Excel, and if you've ever looked at Microsoft's compatibility guidelines, it's remarkable, right? An Excel document from the 90s should still be openable and usable in today's Office. And so It was really important to bring forward all that compatibility stuff. And so the story goes that they took this library and instead of re-implementing it in JavaScript, just compiled it to WebAssembly, and it runs somewhere in Office 365 today. And that was the kind of case that WebAssembly in the browser would have considered a major victory. Figma did their high performance vector stuff that way. Number of websites use it as a utility platform to compile Rust code to WebAssembly and run it there. Go, a wide variety of languages now, Python and PHP and Ruby as well. And so in the browser context, that was the problem they were trying to solve.
Yep.
But in order to hit the checkboxes that you need to create something that can run in the browser, you got to think about a few things, right? Security is one. Not only does the WebAssembly runtime need to be secure from somebody using it as an attack vector to, download an opaque binary into your browser and then try and steal your system passwords or try to execute shell commands, right? That's sandboxing that has to be done. But they also wanted to sandbox the WebAssembly off from the JavaScript runtime in which it was interfacing. So they had a very, very strict security model that was based on capabilities. You could turn capabilities on and off. You could inject things into it that allowed it to call out, but you couldn't, but it by itself ran in a fairly isolated way. So that was one. Cross-platform and cross-browser, another thing that you had to have, which meant WebAssembly from the get-go had to run one binary format in Windows and Linux and exotic operating systems on Intel, on ARM, on Mac, on all the variety of silicon and all the variety of operating systems and all the variety of browsers. And so as it got going, this consortium of Safari developers, Chrome developers at the time, Microsoft Edge developers and Chrome developers all got together and worked on, Firefox developers all got together and worked on this in unison through W3 to build an environment that was it was very neutral, right? Very secure, very neutral, and solved just that particular problem.
Interesting.
And and it was so it was, as far as web standards go, it's probably one of the ones that's had the easiest lifespan, right? And JavaScript took 10 years to get standardized. WebAssembly started as a standard. But then as it got going, then people started saying, well, wait a minute, these features are not browser specific features. Security, sandbox, cross-platform, cross-architecture. This is sort of like Java with a different set of founding principles, right? Instead, Java is supposed to be able to do lower level, more system-y like things. And by default, it's fairly permissive about allowing you to access the file system and the network and things like that. WebAssembly was supposed to be lighter, faster, but also have more restricted runtime. And that's why you saw it start to branch out from the browser. And Amazon and BBC, the streaming players that you probably have on your Roku or Apple TV or whatever, they use WebAssembly to run there, so you can compile a common code base and then move it across BBC said, I think they support 3,000 different SKUs at the time they wrote about their WebAssembly usage. So you see it in embedded. Fermyon's interested in server side. Shopify uses it for plugins in their backend. It's been running inside of various databases. So you're seeing it sort of move its way out of the browser into a number of other places where the same kind of concerns about security and portability and performance really kind of come to the top.
Yeah, no, makes sense. It is always fascinating when a technology starts out in a place and then people start going like, oh, but it's useful here, it's useful there. I can see it adapting to things and be adjacent to things. And Ruby is another good example of that, right? It was supposed to be a shell language. It was supposed to be sort of like an alternate syntax to do shell scripting, and we all know it as a web development language primarily. And even Java was going to be an embedded language. Well, the internet, I guess, is going to transfer military secrets and physics papers, and look at where it is now. So exactly. Fermyon, your company has sort of taken this. It focuses more on some of the things that are a little closer to your background in terms of developer experience, paths, if you will, in some cases serverless. What have you guys learned over the last, you mentioned kind of in the introduction in the beginning, you guys have been working on paths since, Kubernetes 1.1 days, which probably puts it back 7 or 8 years, maybe even 9 years, since we're now on the 10th anniversary.
It's coming close to the 10-year mark, I'm afraid.
Well, you're now addressing it sort of in a slightly different way, but I can imagine developer needs are sort of developer needs. It's not as if they've magically stopped testing code or doing integrations or something. But like, what have you generally learned from that perspective of addressing sort of developer needs so that you're not introducing more complexity than they need, or at what line should a path stop or start, or how much should they have to know versus what sharp edges do you expose to them? I don't know, what do you sort of learning these days in that space?
And the short answer is a lot, right? Some things good, some things hard lessons, right? I think that as developers, we kind of expect the landscape to change over time. We expect new versions of things to come out, new tools to come out. But at the same time that we expect and actually kind of yearn for that change, we also want stability and continuity, right? I don't want to come in today and find that, I'm writing Go code, happen to be writing Go code, right? I don't want to come in today and find out that they refactored the entire core library of Go, and now I have to relearn all the APIs and rewrite all the... So a lot of building developer tools has turned out, and this is true with WebAssembly and with every other developer tool I've ever used, has turned out to be trying to balance the user's desires and needs for change, the developer's desires and needs for change, improvements, bug fixes, things like that, with the need for stability and continuity. And, that plays out from building a path to, WebAssembly's core infrastructure itself, right? And so here I'll throw out a couple of the things that we've learned and kind of end with some of the things that we still kind of struggle with. On the path side, I think I've worked on 4 or 5 different path systems over my career, kind of going back to Staccato and Deus was building one, and, in each case, there's the easy part of the story, which is how do I make it possible for someone to, seamlessly upload their application somewhere and have it run. And that's actually the easier part. You need to schedule, you need to do some of those kinds of things, but that's actually the easy part. Then there's the next hardest part from that is figuring out how to wire up services so that when they need a database, there's a database there, right? When they need a key value store, there's a key value store there. When they need to map their domain name, there's an easy way to map their domain name. But then the hard part is the developer experience part, where you're going, actually, how do I fit this whole concept of building, deploying, wiring up services into the way a developer needs to work in order to get the job done? And I would imagine that if you interviewed the Heroku developers who started Heroku, which I think is always been the most successful paths as far as developer experience and market adoption, if you interviewed them about what they thought that developers were going to need to do, and then you walked into Salesforce today and interviewed the current Heroku development team, you would get some very different answers about what developers expect and need out of a platform, because as the applications, sort of mature themselves, the things running inside of the platform mature themselves, the developers expect more and more again, right? It's that, they want the continuity of the platform, but they want new features, and they want it to be easier, and they want it to be faster, and they want it to support more things. And so PaaS always is sort of like walking this tightrope of making sure you can make the development process itself fairly easy for the developer. Right. While still making it, and that means everything from DevX to deployment, right, and runtime, day 2 ops, to while at the same time giving them more and more services. So when we started building one for Fermyon, we kind of went to the drawing board and said, okay, let's rule out some things that we know are going to be A, hard, and B, duplicates of things already done and done well.
Right.
And a lot of that was sort of like the long-running server processes that, start and run for hours, days, months, quarters, whatever. And then we said, okay, well, what did we hear from Microsoft are the ones that are harder for developers to do in sort of that PaaS-y kind of way? And the answer was serverless, right? Lambda is very... there are a lot of rough edges on Lambda, right? I one time walked through the Hello World tutorial. It took me 40 minutes to go from start to finish. And I know what I'm doing. And it took me 40 minutes. It was so frustrating. And so we said, okay, well, and that style of Lambda serverless function has been taking off in popularity. It keeps growing and growing and growing. And, about a year ago, a great book called The Value Flywheel Effect came out, and Adrian Cockcroft, who architected Netflix, wrote the foreword to this and was like, let me tell you about how cool it is to be this productive with this such a small amount of code. And so we took that on as kind of the big challenge when building a PaaS-like framework, is can we build one that would really sort of specialize around that? And that allowed us to lean into WebAssembly's strengths, like its ultra-fast startup time, smaller binary sizes. And so that was kind of the big first lesson was, if we're going to do PaaS again, we have to do it in a way that's going to help us walk that tightrope. And one of the ways to do it was to make a simplifying assumption about what kinds of applications we were going to support.
Right. Yeah, I've always said PaaS is one of those things that sounds wonderful, in theory, on slides, in a keynote presentation. The idea of saying like, look, your developers are unbelievable at creating value for your business through technology. Mm-hmm. Why wouldn't you want to unleash them, to kind of just take the shackles off them, allow them to do these types of things? And the analogy I always use for people is they go, why hasn't PaaS been sort of the, just takes over everything? And I go, well, let's pretend you wanted to run a business, right? And you wanted to be as efficient as you wanted. You wanted to run a restaurant, for example. I said, let's just say I gave you a McDonald's, and they were like, okay, great. And I said, and at that McDonald's, you only get to serve the numbered menu items, right? Value meal number 1, 2, 3, 4, however many there are. They most likely would go, oh, that would be awesome. I wouldn't even need the front of the store. I could just run everything through the drive-through. Everything would be a 1 through number 7. And then you go, and what do you do when the guy doesn't want ketchup on his burger? And what do you do when they go, I don't really want to pay for French fries because I think it's too expensive, or I don't want to pay for French fries because I'm on a gluten-free diet or something. Mm-hmm. You can't service that customer, right? And you start to, like you said, you start to get into the rough edges of things, and you start to realize that, like you could solve those problems, and you can say, look, this is what it does. And that was essentially what kind of Heroku did at the time, was they did what they did, and the people that liked what they did it. And then we kind of got into the enterprise, and people would, in the enterprise, people have these fascinations of like, one platform will replace everything we do. We want to make a strategic architectural decision. And then you realize like, oh, well, if that's the case, then you're not serving the value menu anymore. You're serving everything you want 24 hours a day, inside, outside, this, that, and the other. And they go, oh, well, that's going to be harder to do because to serve everybody, like you got to do it 10 different ways. And it's like, that's no, but I think what you're hitting at is all of that is super important. Is you do we have gotten considerably better at PaaS over the years, right? From the earliest stuff to sort of where we are now. It's almost mostly expectation settings more so than, are we going to be, 10x better than the last thing, right? 2x might be fine. It's really more expectation setting.
I mean, I love the McDonald's example because that's basically our answer to that was, well, maybe we should go with the Raising Cane's model. So Cane's, for people who have not had Cane's, right? They've got like what, four different ways you can have fried chicken, fries, coleslaw, and a piece of toast, right?
Yep.
And you can customize to an extent, but there's just not that much. There aren't that many permutations that you can customize.
Yep.
And I think serverless might be the Raising Cane's of the world. And there's a certain class of workload that you do. It is not the major financial system that has, that spawns 400 threads and manages a giant thread pool and 36 database connections or anything like that. The serverless functions are very much like single purpose, gets a request in, handles the request, sends back a response, shuts down. It's stateless. They tend to be what we would call satellites to large applications, right? They augment core applications, but they often aren't. Or you can build like microservice style things. So I think I love that fast food example because it really works. Our goal was to say, can we simplify the menu in the first place so that we only have to accommodate a smaller number of permutations? Yeah, and that was the way we tried to take on the complexity factor, because I think you're right. I think, with Heroku, ultimately you go from the McDonald's model to how can we be everything from, McDonald's to a Michelin star restaurant for all the different people who want to use Heroku as a platform. Yep. And the answer is it's just too big and too cumbersome. And you either introduce so much complexity that the developers can't keep up with it, or you're missing features that are cutting out huge swaths of your audience. So by focusing a little more, we hope that we take the best part of PaaS and we match it with a technology that's well suited. Right. And there is
there's a lot of space there. It's serverless is a little bit like the other ones in that if you go, look, this is what it, and at its real core, serverless, and for the people that weren't sort of super religious zealots about it, where it was like there's serverless and there's nothing else, you sort of said, look, at the end of the day, it's the most like the definition of what cloud computing is supposed to be, which is like it's fully on demand. You should know exactly what you pay for it. You shouldn't have a lot of idle resources. It's still going to give you some basic primitives that you want. It looks like compute, or it looks like storage, or it looks like an API integration. And then they started going, well, but I want it to run for these instantaneous things, but I also want it to run for this long-standing Java workload, and it has to, and you get into the permutations again, and so the foundations are all sort of there for interesting stuff.
Yeah, I think you hit on one of the core. In my career as a developer, what you just described is the core thing that we all have to figure out how to balance and at times resist, which is it's all ones and zeros. So you can grow anything into anything else, right? You can turn your package manager into an application platform. You can turn your scheduler into a word processor. It's just, at what point are you going to say, I'm not going to start adding these features? And you're right. There was kind of, in any of these movements, you'll see maximalists who are, or zealots, as you call them, right? Who are like, this solves all the problems, right? It's a content management system with a third-person shooter video game built in, right? And you're going, exactly. No. Play to the strengths of the technology. And I think that was a serverless. I was actually looking at this about a week ago. If you go look at Google Trends and check out the Google Trends for serverless, it's M-shaped. In 2016, it started trending up. In 2018, it peaked. In 2019 and 2020, it troughed. I mean, it just took a steep decline. And then in 2022 started going back up again. And now, so I guess it's not an M because we haven't come back down after that. Yeah. But you definitely, there's a pronounced valley. And I think what you just said is the reason why, is that we saw all this promise, and then you saw these kind of maximalists come in and say, it's going to do everything, right? And everybody needs to migrate to this. And then a whole litany of products with serverless as buzzword entered the market, and we lost sight of what was good about it and what we were actually trying to do with it. And the term itself became essentially meaningless. And then, that fad died down a little. And I think we're seeing it pick up again with this more specific definition attached, that this is a type of, or it's a development practice where we say, it's going to handle an event, right? It's event-based programming. It's going to handle an event, and then it's going to shut down.
Right.
And the server that we're doing without, right, the thing that is the less in serverless is long-running daemon process that keeps a port open for a long time and manages multiple threads. We're just going to say it's an event handling framework. And that seems to have once more kind of triggered this deeper interest in it. And that, I think, is healthy, right? I think maybe as a community, we weathered the worst of our proclivities toward complexity and said, okay, the simple thing actually is the desirable thing here. We've reclaimed it. Let's go with it.
Yeah. No, that's good to hear. It's good to hear. We are, it's June. We are sort of in between. We're in the middle of trade season, but we're also, for this community, we're kind of in between KubeCon events, right? Europe was in February, I think, or so in March, in Paris, and then we'll do this again in November. The CNCF has been a fantastic steward for all these open source projects, and at the same time, every project is in the CNCF, and so you get the constant thing of like, well, what's the focus, and the landscape is really big, and so on and so forth. I'm curious. And I'll say this, with great respect, like when you guys first started talking about WASM and you sort of brought it to the CNCF, it was very much in the, hey, it's hot, right? And I mean that in the sense of like, people were like, okay, Kubernetes is kind of stabilized and service mesh is sort of, figuring out what it's going to be and some stuff. And so you had this new thing that people could be like, okay, cool. This is a new area of focus. It makes sort of logical sense. It's adjacent to Kubernetes and so forth. Where do you think we are today with kind of, let me rephrase that. How are you guys navigating the CNCF having so many focus things? And then obviously there's the gravitational pull of AI, whatever that's going to mean in the CNCF. But how are you keeping WebAssembly kind of forefront especially in those kind of events where there's just so many things going on?
Yeah, I personally had a little bit of a rough journey over the last couple of years, even from Detroit, a few years ago, in that I came out of being very Kubernetes focused for a long time, right? Pre WebAssembly, very focused on Helm, on Brigade and Draft and all these CNCF projects working on various aspects of Kubernetes. We did service meshes. I came out of that period and had this feeling that WebAssembly was going to help us get to a new class of cloud computing. And I kind of went through a period of not being able to see how Kubernetes was going to fit into that story. And consequently, that caused me to say, how is CNCF going to fit into this story, right? Is CNCF going to stagnate, or is CNCF itself going to be able to grow? And I think CNCF is one of the best examples of a really well-run organization. Nobody else has been able to ramp that many projects up that successfully, run successful conferences year after year, successfully govern all of these things, and at the same time, get people excited about each new thing as it comes along. So I think they're just a phenomenal organization. And I went through this period of time going, I don't see how Kubernetes is going to fit into this new future that we're thinking about at Fermyon, but I do see CNCF being something that should remain relevant. And so our first couple of iterations on working with CNCF and starting WASM Day and getting involved in various projects there was not terribly Kubernetes focused, and it wasn't terribly well meshed with the other things inside of that ecosystem, the service meshes, the telemetry platforms.
Right.
And a lot of that was because we had started working on Nomad as our preferred scheduler, because Nomad is a process scheduler and consequently a lot easier to deal with, a different kind of runtime. But two things happened over the last few years. One of them is on the Kubernetes side. I'm deeply respectful of the work that Tim Hawken does, that Clayton Coleman has done, and in all the individual developers that have worked on trying to make Kubernetes more flexible. And not necessarily so tied. Originally, Kubernetes' original description was it's a Docker container runtime, right? Docker is the only game in town. And now, it's gotten so much more elegant in the sense that different pieces that were never pluggable before are suddenly pluggable. And so on that side, Kubernetes started moving toward what we were trying to do with WebAssembly. And then on the WebAssembly side, there's both a negative story and a positive story to this, right? The negative story being when HashiCorp changed their license, it changed how we imagined being able to do things. So when Nomad's license changed, we went, it's really hard to convince people to run Nomad when the license is as restrictive as it is. That was very hard for us because I still remain huge Nomad fan. But that meant we had to sort of give up on one of the beliefs that I was probably holding too tightly, which is Nomad's the scheduler for WebAssembly, right? And the other thing that kind of changed for us is Microsoft and SUSE and Liquid Reply and a few other companies started actually writing the code to bridge what Fermyon was working on, Spin and core WebAssembly and Kubernetes. So we were seeing, on one hand, Kubernetes growing closer to WebAssembly, and on the other, various people driving WebAssembly closer to Kubernetes. And at some point we said, well, we were just blind to the fact that this is actually a much better fit than we ever thought. We just needed to pay attention to how much work was happening around us and not, I have this tendency to get in this mindset that it's like, if we don't move this rock, nobody's going to move this rock. And it turns out that everybody was moving the rocks. And so it's been really fantastic. And so in Paris, at KubeCon in Paris in March, we released with Liquid Reply, SUSE, with Microsoft, we released SpinCube, which into CNCF, which is a platform for running WebAssembly serverless functions inside of Kubernetes. And the thing about it is, it's just so cool that it works this way. It's just after starting from a perspective where I said, I can't possibly see this working, and then releasing something that, thanks to the work of dozens of people, just works great. It was so exciting. And so it changed my opinion about a number of things. First, my own self-corrective, I got to stop looking at things in such a black and white kind of way, but also about, the desire to bring CNCF and Kubernetes forward, right? Nobody was saying Kubernetes today is going to stay this way forever. And I thought they were, but they weren't. And as we watch these things mature, they matured in a direction that I think has ended up being really fantastic for the entire community, but also really exciting for us because now we have this, this ability to run WebAssembly binaries inside of Kubernetes side by side with containers. So you can literally run a WebAssembly as a sidecar to a container, or a container as a sidecar to a WebAssembly serverless function, which is very powerful. And really starts to get us toward being able to right size our Kubernetes clusters, squeeze a lot more performance and density out of them, and cut costs along the way. That's always nice. And that's just an exciting thing. So I think, this kind of full circle thing for me has been, I am really excited about where Kubernetes and CNCF are, and that, even with my own, blindness, a couple of years ago, looking at it now, I'm thinking this is just great. This is how an open source community really ought to function, and it's good to see it happening. Yeah.
Well, and it's interesting, and I'm going to sort of wrap up there. I'll throw one last comment out. I was going to ask you about, because to a certain extent, like WASM and Kubernetes have had sort of an interesting relationship, and again, it's part of it is like you said, if you go back a couple of years, sort of what WASM was designed to do versus what Kubernetes was designed to do. And sometimes people put them together. And then sometimes you have situations in which, the media loves to, and I've been meaning to ask, I should have asked Solomon. We did an interview with Solomon not long ago. It'll release here in a few weeks, but to ask him sort of a similar question in that, the media, while new technology is always sort of interesting to them, what they always really care about is wins and losses. Who's going to win? Who's going to lose? What's going to die? And as many times as you try and tell them, like, look, there are technologies that don't get adopted, like those things happen. But once something is well adopted, like it doesn't tend to go away, right? And so this question you constantly ask, people constantly ask about, like, well, will WebAssembly get rid of Kubernetes? Will serverless get rid of Kubernetes? And it's like, those are fine questions to ask. They're kind of naive. It would be one thing to have asked it 7 or 8 years ago. Like you could have said Kubernetes versus a Deus, or Kubernetes versus Cloud Foundry, or something like that. So it was really interesting to hear how you've adapted, because I remember when we had talked about it a while ago, you were like, look, Nomad just is, like you said, it's a better fit for the things that we try and do. And I think you were pretty realistic about being like, and I know where Nomad is from a market share perspective, but at the same time, like sometimes when you put 2 and 2 together, you get 5. And so, it is interesting to sort of see how that's evolved in that space. And it's good to hear because the last thing you want to do is have something interesting and then have to abandon it because it doesn't, like you get, again, zealous or religious about, there's only one way to fix something.
And I do think, one thing that is now for sure, given the way you kind of framed all of that out, is that WebAssembly hit critical mass, right? The majority of important programming languages now support WebAssembly, right? We keep track of this every year, and we're watching more and more languages get added to that matrix. InfoWorld did an article a couple of days ago that was called something like 11 Surprising Applications of WebAssembly. And I saw that article and I clicked on it to see, are there any of these that are going to surprise me? And the answer was yes. I'm wow. Whoa, I didn't know they were doing WebAssembly for this kind of stuff. And that's delightful, right? It means we kind of hit critical mass and people are seeing broad applications to do with it. So I think you're right about that. It's past the point where it could kind of fade into the sunset in, the next 6 months or something like that. But then the second part of that you alluded to there, and the part that Kubernetes is grappling with now, right, is you want to remain, you want to be correctly growing, right? You don't want to, again, it's that balancing of, meeting the demand for change and meeting the demand for stability. And as Kubernetes gets bigger, the demand for stability is more important, right? But the demand for change is still there. Right. I think WebAssembly is going to hit that same kind of moment in about 2 years where the brunt of the development part is going to have to solidify so that we can get into more, so the balance of the scale can shift a little bit and we can give people something stable. That, though, comes with a lot of pressure because we're looking at the technology going, we really only have a couple of years to finish things like the component model and the WebAssembly, the WASI, WebAssembly system interface, before the demand for stability locks things in. So it's an exciting time, and the next couple of years I think are going to be just like the year 3 and 4 of Kubernetes. I think we're going to see that kind of thing happening in the WebAssembly world, where you see sort of like this explosion of innovation, then it kind of contracts a little bit, solidifies into the thing we're going to build, and then we start working off of that as a basis for the future. Yeah.
Matt, I'm gonna wrap it up there. We covered a ton of different topics. I appreciate kind of all of your insight, going left and right and in the middle and everywhere we kind of went today. And not only that, providing us just a ton of sort of historical context and technology context. So thank you very, very much.
This was so much fun.
No, I appreciate that. I appreciate it. Well, listen, for folks who want to engage with you guys, we put some links in the show notes for SpinCube, for the Fermyon homepage, for the links when Matt and I first talked about this. So lots of stuff for you to dig into. Matt, any last thoughts about kind of, maybe things for folks to be thinking about maybe between now and the next KubeCon here in North America?
I mean, I think, and largely we talked a lot about developers today. As we go into summer, it's that period where, your colleagues are out, you've got a little bit of extra time. I think now is a great time to just take a look at this ecosystem, get a little bit educated, play around with it, and see what kinds of things you can build in it. And then, that may just awaken the realization that, hey, we're missing one of these things over here. I can build one of these, because we're very much in that kind of proactive building phase of WebAssembly now, which means there's plenty of opportunity.
Good stuff. Well, folks, on behalf of Aaron, I want to thank Matt again for his time, for all of his insight into what's going on in the WebAssembly world, and something to definitely keep an eye on as you're starting to plan your Q3, Q4 trips, if you're getting out to KubeCon and other places like that. So with that, again, thank you for folks for the time. Thank you all for listening. Thanks for helping us grow the community. Thanks for the feedback that you always send us, show@thecloudcast.net, or if you're rating the podcast wherever you listen to your podcast. So with that, I'll wrap it up, and we'll talk to you next week.